good morning or afternoon, depending when you're watching this. So we just finished up our second unit on logic and reasoning and proofs. So we're starting our third unit, which is dealing with parallel lines and relationships formed from parallel lines. So we had defined parallel lines earlier, just a refresher. Parallel lines are two lines that are coplanar and don't intersect. The symbol we use for parallel lines is either two vertical lines that aren't crossing or two diagonal lines that aren't crossing. So if, say, AB was parallel to CD, we could have two vertical lines like that. Or let's say line L was parallel to line M. By the way, that's a cursive L. That's how I write my cursive L, if you see it. And we could do diagonal lines like that. Either one of these is fine. If you have a diagram with parallel lines to show that the lines are parallel, what we do is we do arrows in the same direction on each line. If you have more than one pair of parallel lines, to differentiate between the pairs, you put additional arrows on. So two arrows means it's parallel to every single one with two arrows on the line. Be sure that you make that bend in the arrows, otherwise it's going to look like tick marks, and tick marks mean congruent, and lines cannot be congruent because they're infinitely long. So those are parallel lines. You're mostly familiar with those. You guys dealt with them in Algebra 1. But more in the sense that they had the same slope when they were in the coordinate plane. Now we're going to be going more of a geometric approach to that. So, excuse me. What's going to create the relationships is not so much the parallel lines, because if you have two parallel lines, let's say that's line L and that's line M. If you have two parallel lines, line L and line M, really there's nothing with them. They don't create anything, except they divide the plane into three different sections, that above L, between them, and below M. What would create a relationship is if we brought a third line into it, one that intersects both of them. If you have a line that intersects two or more other lines at distinct points, so that means they couldn't intersect like this. Like that line intersects these two lines at the same point. That's not two or more lines at distinct points. Let me get rid of that. A line that intersects two or more lines at distinct points is called a transversal. And that transversal is what creates the relationships. The transversal is what creates the relationships. Now, a transversal, I'm going to save this slide for later. A transversal doesn't need to intersect parallel lines. This line A and that line B, they're on the same plane that is this whiteboard. And this line intersects them at two distinct points. I'm just going to call that C. So that's still a transversal, even though the lines aren't parallel. But if you have two lines in a transversal, every single time when you are dealing with the situation of two lines that are transversal, that means there's two distinct intersections. And at each intersection, you're creating 4 angles. 1, 2, 3, 4. And then there's 4 down here. We're going to have a lot more angles named with numbers. All right, we're going to have way more angles named with numbers. And they're going to have special relationships. One of those relationships is like angle 1 to angle 5. Now we can classify that relationship because they're in the same relative position with respect to their vertex. One is to the top left of its vertex. It's above it's a line and to the left of the transversal. And 5 is to the top left. It's above its line and to the left of the transversal. They're in the same corresponding position. So that's why we call angles like that corresponding angles. So angles like that are corresponding angles. So that's angle 1 and angle 5 are corresponding angles. Angle 2 and angle 6 are in the same position. Angle 3 and angle 7. And then angles 4 and 8. All right, so those are called the corresponding angles. Another pair of angles that we can classify in this diagram. Well, actually, before we do the other ones, let me just say, anything between the two lines, that's interior. Anything outside the two lines being cut by the transversal is exterior. So 1, 2, 7, and 8 are exterior angles. 3, 4, 5, and 6 are interior angles. So with the interior angles, we're not really going to relate 3 and 4. Those are already a linear pair, so we don't need another classification for that. So 3 has a relation with 4, so 3 also needs a relation with 5, and 3 also needs a relation with 6. If we're working with 3 and 5, they're interior, and they're also on the same side of the transversal. So they have a very, very strange name. We call them same side interior angles. So that will be angles 3 and angle 5. They're on the same side of the transversal and they're interior. And then 4 and 6, they're on the same side of the transversal and they're interior. So if we want to get really complicated here, maybe if instead of dealing with interior, we said same side exterior angles, it would just be like 3 and 5 where they're on the same side of the transversal, except they'd be exterior, so 1 and 7. or 2 and 8. So that's when we're dealing with them on the same side of the interior of the transversal. So what if they're not on the same side of the transversal? So this would be like 3 and 6. Angle 3 and angle 6. They're still interior, so it's got to be something interior angles, but they're not on the same side of the transversal. They're on opposite sides. They're on alternating sides of the transversal. So we call those alternate interior angles. So that will be angles 3 and 6 and angles 4 and 5. All right. And similarly, if we have same side interior angles, we also had same side exterior angles. If we have alternate interior angles, we also have alternate exterior angles. So these would be the ones on the opposite sides of the transversal, but exterior. So 1 and 8 and 2 and 7. Oops. And just a reminder, these are just my ampersands. That just means my and. That's just how I write it, okay? So we've got all these classifications. These classifications only tell you their positioning. These say nothing about their measures. These say nothing about their measures. The only thing we know about the size of these angles is that angles 3 and 2 are congruent. Angle 1 and angle 4 are congruent. Angle 6 and angle 7 are congruent. And angle 5 and angle 8 are congruent. And we also know a bunch of supplementary pairs: 1 and 2, 2 and 4, 4 and 3, 3 and 1, 5 and 6, 6 and 8, 8 and 7, and 5 and 7. So that's all we know about their measures. But that brings us to our next set of rules. Our next set of rules is going to help us with their measures. And it's only going to help us when the lines are parallel. So I told you this slide would be coming back. So 1, 2, 3, 4, 5, 6, 7, 8. So we've got our angles. We know how to classify them. We know the corresponding, the alternate interior, same side interior, alternate exterior, and same side exterior. Now, unfortunately, one of our rules is going to have to be a postulate. We need to make an inference about one of the relationships in order to prove the rest of them. And the one we're going to make an inference about is the one that doesn't have a partner. Alternate interior has alternate exterior. Same side interior has same side exterior. So the only one that doesn't have a partner is corresponding. So like angles 1 and 5. And if we're looking at that, they look to be congruent. And that's true. An easy way to do this, to show it, would be just to trace it. I don't have any tracing paper here at my house because I don't have children. But if you have any tracing paper, draw 2 parallel lines, draw your transversal. If you trace one angle, you can bring it down to the corresponding angle and it's going to match up. So corresponding angles are congruent when the lines are parallel. This is our corresponding angles postulate. And we can abbreviate COR angles postulate. And I already wrote out corresponding angles on a previous whiteboard, so you guys saw what it looks like. So the corresponding angles postulate. It says if two parallel lines are cut by a transversal. Very important that it's parallel. I don't need to underline the lines. I mean, it's important that they're lines, but it's very important that they're parallel. If two parallel lines are cut by a transversal, then the corresponding angles formed are congruent. That's our corresponding angles postulate. We can't prove it, but it looks in general to be true. All right? We can't prove it, but it looks in general to be true. So that's our relationship. If the lines are parallel, the corresponding angles are congruent. So next, let's look at another pair of angles. Let's just go down the line. The next one we have was same side interior angles. Well, angle 3 and angle 5 do not look congruent. But angle 1 and angle 3 have a relationship. They're supplementary. So if angle 1 is supplementary at angle 3, and angle 1 and angle 5 are congruent, it should follow suit that angles 3 and 5 would also be supplementary. And we would be able to do a full proof of that. Just for the time of this video, I'm not going to do the full proof of that. But we could, and I may ask you to do it at some time on your own. But that is our same side interior angle theorem. And you can abbreviate the same side interior angles as SSINT angles. So this says that if two parallel lines, again important that they're parallel, are cut by a transversal, then the same side interior angles formed are supplementary. Pretend I didn't poorly space that out. So the corresponding angles are congruent, and the same side interior angles are supplementary. So the next relationship we had was the same side exterior angles. Well, angle 1 and angle 4 are vertical. Angle 5 and angle 8 are vertical. Angle 3 and angle 2 are vertical. So wait a minute. Angle 2 and angle 8 are same side exterior angles. If 3 and 5 are supplementary, and angle 5 is congruent to angle 8, and angle 3 is congruent to angle 2, wouldn't that make these two also supplementary? So that means the same side exterior angles are also supplementary. Now I'm going to be very lazy here and just do this. The same side exterior angle theorem. If two parallel lines are cut by a transversal, then the same side exterior angles formed are supplementary. All right, look at that. Wow, that was very quick. So the same side interior angles are supplementary, and the same side exterior angles are supplementary. And if you felt that went too quick for you to copy down that slide, just remember this is a video and you can pause it. And then the last two were the alternate interior angles and the alternate exterior angles. So that would be like angles 4 and 5, or angles 3 and 6 for the alternate interior angles. Oh, wait a minute. Angle 1 and angle 5 were congruent by the corresponding angles postulate. Angles 1 and 4 are congruent by the vertical angles theorem. So both of these are congruent to angle 1. So if angle 1 is congruent to both, don't they have to be congruent to each other? Yeah. So that's our alternate interior angle theorem. Alternate interior angles theorem. If two parallel lines, again, must be parallel, are intersected by a transversal, I don't know why I said intersected this time and cut on the other ones. Doesn't really matter. It means the same thing. Then the alternate interior angles formed are congruent. So that's our alternate interior angle theorem. And our last relationship is the alternate exterior angles. Well, that would be like 1 and 8. If 1 is congruent to 5 and 5 is congruent to 8, wouldn't 1 and 8 be congruent? Yeah, that's transitivity. So the alternate exterior angle theorem, let's fix that and fix that. So it's the same as the alternate interior angle theorem, except spelled differently. There we go. So these are the relationships that are formed when you have two parallel lines and a transversal. Remember, it has to be parallel lines. And other than that, that's it for this section. Have a wonderful day.